Thank you, everyone. My name's Eric, this is Yak, and this is Tom. We're really excited to share with you what we've been working on so far. Our project is an AI hospital, very small version, where we basically simulate doctor-patient interactions and doctor-doctor interactions, and we kind of experimented with ways that the doctors communicate with each other to try and find out what the best way of communication is using AI agents. And just a bit of an introduction of what AI agents are, if you're not aware. So basically, right now, everyone kind of just puts their questions into ChatGPT and then asks the one AI to output an answer. AI agents are kind of like a step above this, when you get the AIs to kind of talk to each other and you give them tools to interact with their world, and they can solve more complex tasks together instead of just one by itself. And so that's kind of the framework that we used. And one such more complex task is diagnosing a patient, obviously very complex. And so the kind of 3 experiments that we decided to run was first changing the number of doctors that interact with the patient. Secondly, whether they're specialists or how many specialists there are and how they interact. And the third was the number of handovers. So for the first experiment and kind of in general, we did this by setting up a chat room between the AI and the patients, who are also AI, and given a case report from the NEJM cases, so the New England Journal of Medicine, which are supposed to be a little bit difficult. And then the doctors, depending on how many there are in the chat room, can talk to the patient, take a history, and then discuss with each other, and then come up with 3 differential diagnoses. And they were scored 3, 2, 1, or 0, depending on where they got the differential, or not at all. And the results were actually quite interesting. So just the one doctor by themselves, using the NEJM cases, was only able to get about 35% correct, taking a history. And all the way up to 4 doctors together were able to get 47% correct, which is actually interesting. It might not be that surprising that more doctors do better to you, but why it's interesting to me is that each of the doctors are actually just the same person, really. They're all just Google's Gemini model with the same knowledge, with the same data sets. They're all actually just thinking the same thing. But just by making them talk to each other, they're able to do a lot better, which is very, very interesting, without any extra data or anything like that. We also evaluated them in some other models, so like doctors marks per question, and then like when they kind of got the differential, but it's a bit too in-depth to go into that today. But if you have any questions about kind of why this happened and like some of the other things, please ask us afterwards.
So I investigated like implementing specialists, so expanding upon what Eric said. So pretty much what I did is, so Eric had like a general doctor, and so what I did is essentially add a label to the doctor. So the doctor would essentially, like, I'd say in their system message, like, you're a cardiologist or you're like a hematologist. And just by adding the label, we were to see different results. Right over here is like a control flow map of pretty much how our system works. So we'd initialize the case, the patient would read the case file, and then it would internalize the case and become the patient and act it out with the doctor. And so then it would talk to the doctor. Well, first it would go to a nurse, which would triage it to the specific specialist, and then the doctor would figure out how to diagnose the patient. And then we'd have another agent that evaluate whether it got it correct or not. And so I investigated one specialist, and then having 3 specialists working together. So in terms of the results, so when we had one specialist, so the nurse would choose a specialist that the patient would fall under, and it got an accuracy of 48%. And then when we increased it to 3, like the nurse would choose 3 specialists, which it thought it would do, like which would be best suited for the case, we actually got an accuracy of 84%, which is a massive increase, which we weren't expecting. And also with these are some examples of the conversation. So this is one specialist, and so we'd the nurse would triage it, and then the doctor. This is just a really short form of the conversation, and so the doctor would generate 3 differentials, and then also with the validator, it would validate it. And so we can see the diagnosis with gastric outlet obstruction. That was like it comes under, I guess, the trichobezoar, which was like the case we had. It is you can see it's like it doesn't really match up, but it essentially is like the same thing sort of. But except when we gave to 3 specialists, it was able to much more, like, I guess, narrow down on the diagnosis. So it actually got bezoar. So it actually became like way more accurate as you went on. So moving on to Tom.
And I was looking at the number of handovers. So the start was the same with the patient getting triaged, but then a doctor looked over all the notes and wrote a bit of a patient note there. You can see the chief complaint, history, whatever. And then another doctor read that note and did a verbal handover. And I've got a loop there, so they just keep repeating that cycle n number of times. So wrote down a patient note, did a verbal handover, wrote a patient note, did a verbal handover. So you'd expect information to be lost as it went along, right? And I've kind of covered it up at a good spot to make it look like it's going down. But it actually went up, which is really surprising. I've got there 10 handovers as well as just a bit more of an extreme example, and something gets lost along the way there. And a bit more there, the number of correct diagnoses also goes up following the mark distribution. And surprisingly, the third differential was more common to get right than the 10th handover.
So in terms of limitations and improvements that we found, so in terms of like the conversation length, so for our patient-doctor interactions, we set a max turns of 10. And so that we often found that that wasn't even long enough to simulate the entire conversation. But we also had like compute restrictions, so it would often take a really long time to process these cases. Another limitation we found was API limitations. It was pretty slow. It would take like 3-4 hours per experiment to run. And also it cost a lot of money. I think we ended up spending $362 of Google credits to run through all this. Some improvements we were thinking of is fine-tuning a specific model for medical reasoning and conversation. And this already exists with Google's Amy model, but this is like a closed source system. And another thing we were thinking of is increasing the number of modalities as an input, so it can also read and see and interpret X-rays and ECGs, for example. Also, we were thinking about like comparing this against a real team of doctors. So like how does like an AI team compared to like a real doctor team? And also currently the model only focuses on diagnosis and doesn't look at treatment at all. So that's another area of exploration.
Right, so you might be wondering where this fits into real life. So I think ours is more of a basis of what can be. So this of what we did doesn't necessarily have any clinical correlation, but we believe it could be built up. So a few examples we have is something like a large scale simulation of a hospital. So things like you have your admin staff, your nurses, the family members of the patients and things like that, with the main goal of improving the patient outcomes. So we'd be searching for things like any sources of information loss or any inefficiencies to improve like management. We could also look into healthcare specific language models with self-improvement. So I think a few of the other teams did that kind of topic, but there's also the possibility of like novel approaches developing if we just let AIs go do their own thing without human interaction. And how does this research matter? So this is only a small study we did, but I believe we demonstrated the ability to simulate patient-doctor relationships with AI, and we also demonstrated that AI can communicate effectively with other AI and even improve upon itself, which is quite an interesting topic. Great, thank you.